Now the last part of the question says this. Show that the volume of the solid obtained when r is rotated through 2 pi radians about the x-axis is this expression. So now the axis of rotation has changed to x-axis and the angle of rotation is 2 pi radian. Okay, I'm going to draw a new diagram for this particular portion. Right, anyway, we want to show required volume is equals to 1/4 pi times 2 minus square root 3. Okay, this is our objective. Okay, now let's draw the graph. Okay, now instead of rotating about the y-axis, they want to rotate about the x-axis. So let's take a look. For region R, it seems okay from the start all the way to have rectangles, all right, that is vertical starting from the x-axis. But as it crosses the line of 1, you realize that the rectangles no longer can touch the x-axis. So it's very difficult for us to talk about how the strips can be rotated about the x-axis, right? But for the rectangles past the value of x goes to 1, if we forced it, all right, to still hold on to x so that you can rotate the strip, notice that there are parts in this rectangle which no longer belong to R. Okay, I repeat, for this particular strip past the value of x goes to 1, there are portions of this strip that do not belong to R. So what's happening actually? If the red strip continued from 0 all the way to 2 over root 3, you notice that we can actually draw this particular diagram. Yes, if we took a full strip from the x-axis to the horizontal line y equals to 4, they actually generate a volume of cylinder. But because all the values past 1, okay, this portion still belongs to R, the blue doesn't. The blue value or the blue part of the curve or the rectangle, when rotated, actually forms this particular portion. So effectively, in order for us to talk about the object, the volume of the object when r rotates about the x-axis by 2 pi radian, I need to take the volume of the cylinder in red, subtract by the volume generated by the blue region. Right? So let's look at how we can find the volume generated by the blue region. Okay, so based on the curve, it looks like this. So I'm interested in this portion. So notice that I can draw a rectangle here. Its height, based on the graph, this point is xy. So the height will be y and the width is delta x. So when this strip rotates about the x-axis, it actually forms a disk with radius y and height of delta x. So the volume of disk here is actually pi r square h. So if I want the entire volume, I just need to integrate this entire expression, for which the limits are x equals to 1 to 2 over root 3. Okay, so now we are ready to begin the question. Okay, so these are the thoughts. So based on the diagram, the required volume would then be the volume of cylinder, right? Subtract by volume of one disk summed from x equals to 1 to 2 over root 3. Okay, so now again, the volume of cylinder, which is the one in red, notice that the height of the cylinder is actually 2 over root 3, and the base radius is actually the height 1/4. So this is just pi r square h minus pi integrate 1 to 2 over root 3 y squared dx. So now our job is to replace y squared in terms of x, for which its relationship of x and y is given uh, by the equation of curve. Right, so this is equals to pi over 16, 2 pi over 16 square root 3 minus pi integrating 1 to 2 over root 3 y square, okay, from here, y square is just 1/4, 1 minus 1 over x squared. So this is 1/4, 1 minus 1 over x squared dx. So this is pi over 8 root 3 minus pi by 4 integrating from 1 to 2 over root 3, 1 minus 1 over x squared dx. Okay, so this is equals to, now remember the objective is to prove this particular expression. Notice that root 3 is in the numerator, not the denominator, meaning we will need to rationalize our sets. Okay, so let's begin. This is pi square root 3 over 24 minus pi by 4. So I can integrate this now. This is x minus x to the power negative 1 over negative 1 from 1 to 2 over square root 3. Okay, 1 over x squared is equals to x power negative 2. Alright, so this is equals to pi root 3 over 24 minus pi over 4 x plus 1 over x 1 to 2 over root 3. So this is pi root 3 over 24 minus pi by 4, 2 over square root 3 plus 1 over 2 over square root 3 minus 1 plus 1. Okay, so this is equals to pi root 3 over 24 minus pi over 4. Now rationalize, this is 2 root 3 over 3 plus root 3 over 2 minus 2. Now if I want to have a single pi over 4, I will need to find common denominators first, right? So this is 24, this is 4, this is 24, this is 4, meaning I need a denominator of 6 from within the parentheses. So let's try to make that happen. So this is pi root 3 over 24 minus pi by 4. So now common denominator of 6, this means the first term will become 4 square root 3 plus 3 root 3 minus 12. So then I'm going to factorize 1 over 6 to become pi over 24. This will be 7 root 3 minus 12. Now I can factorize pi over 24. This becomes root 3 minus 7 root 3 plus 12. I will have pi over 24 times 12 minus 6 root 3. But that's not enough because I need pi by 4 as the term outside, right? So let's try to make that happen. It will happen when I factorize 6. So this is 2 minus root 3. Therefore, I have pi over 4 times 2 minus square root 3 units cubed and shown. Okay, so All in all, for the entire question 3, what you need to learn is how do we tackle a question that deals with area and volume. So that involves drawing of the graph, 2, identifying the region, and finally, formulating a suitable integral for you to evaluate either the area or the volume.